I'll get started. Last time we did this workshop, we had 2 hours. This time we've got 1 hour and 3/4. There's some code examples up here. Download this repo. I think you can either pull it in or just go to GitHub and find it and pull it down. In there, you'll see there's 3 code bases, Java, C#, and Ruby. They're all totally equivalent and they all pass the same tests, but and they all basically exhibit the same kind of legacy code problems that we're going to be talking about. Pick one. You don't need to look at them all. C# and Ruby do work a little bit better because the dependencies between things are clear, like the import statements help you here. So C# and Java. Did I say C# and Ruby there? Yeah. Okay. There's no editor. Don't stress if you can't get Eclipse to work or Visual Studio to work. It's just about reading the code. As long as you can look at it, it's fine. If you really, really do want to run it and you're on a Linux machine, then make run for the language. I'll start the app. Okay? Brilliant. Is everybody at least got the corner shop code now? You can shout really loud if you don't, because I'm about. Do you have it? Brilliant. Okay. Right. Okay. So as you can see, there's only one of me. Kevin Rutherford was supposed to be here, but he's had to pull out at the last minute, unfortunately. But this is something that we've been talking about at a few conferences recently. And what we're trying to, so Kevin is he runs a consultancy firm, XP Surgery. So Kevin will come into your organization, will help your teams become super productive using XP methods. He's very hands-on technically, very, very pro. Good architecture, good test-driven development, good team practice, so on and so forth. I am the head of engineering at a company in Glasgow called Newspaper Club. We help people print their own newspapers. And I was absolutely delighted to find one of our newspapers just lying about downstairs. So what we can do is, this looks like somebody artistic has come up with a concept and built a newspaper, and we've printed it for them. So that's basically what we do, little short run newspapers. I work mainly in Ruby on Rails, but I quite have sort of a bit of an interest in lots of different programming languages. Okay, so what we're here to talk about, the biggest problem in test-driven development is we know this cycle, red, green, refactor. Anybody who was in James's talk this morning, and we were talking about, okay, so we've got to know that there are problems, and then we've got to kind of make little steps to make the world a better place. Okay, that's great, but what are the little steps? All right. So I want this to be an interactive session, so I'm going to start things off nice and interactive. With the people, just turn to the person next to you and spend maybe a minute talking about code smells, design principles, and so on and so forth. I just want you between you to name one code smell, and then I'm going to ask you to shout it out to the group, okay? So 1 minute, go. Come on in if you want to. Yeah, if you've got a laptop, just pair up with somebody who's already set up then, please. Would somebody mind joining this group over here? It's best if we do this in pairs. Okay. Maybe somebody from this table. We've just got an odd number of people, right? Cool, thanks, guys. Hiya. I've asked somebody from there to come over here. We need to work in sort of groups for this, so it's brilliant. Okay, thank you. Okay, everyone. Right, quickly, round the room. Shout me out your code smell. What have we got?
Repetition.
Repetition. Repetition. That's the worst pen I've ever used. It's sort of...
And for here.
Yeah, okay. Okay, you guys?
Naming.
Naming? Or bad naming? Okay, at the back.
Long methods.
Long methods. Over here. So classes with too much responsibility. Okay? Cleverness. Okay, and the comments. Here. Nested ifs. Got it. I know you just joined, so. Okay, right, so I'm filling that. Is there anybody disagrees that these are sort of things we might want to fix? Right. Which one do we fix first? Are you sure?
I would go with naming as well, because until I can figure out what the things are called, it's hard to understand what they're doing.
I'll do that last. I can name things food and bar. Once I refactor things a bit and know what they actually do, then I'll name them.
All right, so we like naming. Anything else? Is a long method worse than nested ifs? Maybe they come together, maybe they don't. Or is... Yeah?
And comments are completely useless. You can get rid of them straight away.
Okay, yeah.
That's true.
Okay. So who's had one of these discussions at work? You know, you're sitting looking at stuff with your pair. Yeah. What do we change first? Well, I think we should change that. I think we should change that. You know, my point is it's very subjective, okay? There is nothing in, you know, we have all this stuff that comes out of the refactoring book. You know, feature class, you know, lazy classes, primitive obsession, long methods, all this kind of stuff. But there's no way to distinguish what's worse than the other. Solid is another one. You know, some nice ideas in there, but it doesn't help us make decisions on what are those little small steps to go from something that's bad to something that's good. All right? And what we're going to talk about today is the idea of Connascence. And Connascence is a way of looking at coupling in your code. So Myers Page Jones wrote a book back in the sort of 90s, trying to take some computer sciencey concepts and apply them to object orientation. And he came up with the idea there's these Connascences, and I'm going to go into what all this means a bit later, but there's the idea of these different types of coupling that you need to look out for. And there's 9 in particular, which are particularly relevant. Later, Jim Weirich, who's very big in the Ruby community, came along and he did a talk where he organized the Connascences into a sort of layers of, like an order to say which are more important to you than others. Okay? So at the moment we have, oh, there's the code again. So what we've got here, we've got some code here that exhibits these Connascences, or a few examples thereof. And the first thing I'd like you to do is get the code, pick a language, which hopefully everybody's done. One of the statically typed languages works a bit better. And in there, we've got some package level dependencies, okay? So I want you to look at just the overall structure of the code, not at the class level. Please do not map the classes here. And I want you to look at drawing a package diagram where the dependencies between them like this. So grab your big bits of paper, work in your groups. We're going to spend 5 minutes or so doing this. Please don't map main. So there's a main function that ties everything together. Don't bother mapping that because it's just going to make spaghetti. And system level stuff like sort of string IO, like Java libraries, all that kind of stuff, don't bother mapping them. So just talk about application code, okay? So, yeah, I'll give you 10 minutes on that then. Okay, cool, right, so hopefully you've all drawn the dependencies. When you sort of organize it, you should be able to see something that looks roughly like this. All right? So is that bit? It's not easy to start the code base and see that, but so this should be great, shouldn't it? I mean, it's hexagonal, right? We like hexagonal. Hexagonal is good. We've got the user interface out here on the edges. We've got domain stuff going on in the middle. We've got layers. We've got nice directed dependencies. Okay. So everything's good, right? Yeah. Hmm? It would pass an if you had that as an architecture review, everybody would go, okay.
So we've seen quite a few two-way dependencies, which aren't.
They are sort of two-way, yeah. I mean, yeah. But even so, if you look at the dependencies, it's roughly organized like that. So by looking at the code, we can derive quite a lot of stuff about it. What we're going to do is explore the reason why this code actually, although it's packaged like this, has lots of other problems in it, which means that there's lots of nefarious coupling going on that you can't see just by examining the code. And that's what we're here to talk about, Kinesins. So Kinesins is a fancy word which means that's born together, lives together. It's a way of saying there are factors within our code base where two or more parts of the system have to agree on one thing in order for the system to work. So we have to have it, okay? We've identified two kinesences already by doing the exercise. That's kinesence of name and kinesence of type. So in order for our code to compile, one part of the code has to say declare a class, declare a package, whatever. And other parts that want to use it have to agree, yeah, that's what I'm going to call you, right? Yeah, so the basket actions has a name. We have to have that for the code to compile. So Connascence isn't a bad thing. It's just part of programming. We've also got Connascence of type. And that's where we were saying, right, okay, basket actions is a type. So we might have interfaces that describe actions, things like that. But the type system, again, and even in Ruby where there isn't an explicit type system, we still have types. It's just evaluated at runtime. So that's another form of Kinesins, but there's 9 of them. Okay. But do you see that the idea that in order to change, if you make a change in one place, it has an effect in another place. So in order for us to change our software, we have to be looking at the coupling. Okay. Oops. Right, so this just demonstrates the idea that warehouse actions has to be able to refer to the warehouse. And they both have to agree that the thing we call warehouse is called warehouse and is of type warehouse. And it's bidirectional, as you said. The two elements have to agree going both ways. Kinesence of name, kinesence of type. Each kinesence, wow. Thank you, Kevin. Each kinesence it's got this idea of type, okay? It's also got we can think about the coupling in terms of the degree to which it's happening. How many elements have all got to agree on one thing? Okay, so if we've got two things that need to use names, that's one thing. We've got a much, much higher degree if everything in the code base if you've got everything pointing in one place, yeah? And we see these things. They're not bad, it's just we recognize that they're there. Finally, the reach is really interesting because the reach is saying how many boundaries in the code base do we need to cross to get there, yeah? So within a package, we want things to be nice and kind of cohesive, yeah? So, it's okay to have a bit of coupling within a package, but if one package is sort of connected across the whole code base to another by internal things, then it's not so good. So we kind of want cohesive packages, but at a smaller level, it's not so bad, yeah? And obviously down at a method level, then we absolutely have to have really, really tight coupling. I'm going to declare a variable, I'm going to go into a loop, I'm going to cycle over things, I'm going to do this, do that, and return a value, yeah? It's really tightly coupled, but it's okay. That's all right. So that's another way of saying that. So the reach, within expressions is less bad, is it sort of acceptable. Functions, worse. Across objects, more. And then when you go across process boundaries, you've got really, really strong coupling when two individual programs need to communicate with each other. Right? And there they all are, okay? So what we're saying is, this is what Jim Wyrick did. He took the 9 Connascences and he said, name and type are the sort of most acceptable, the kind of ones we have to have. We've got convention, algorithm, position here. These are all ones that we can identify by looking at the code base, and then the top ones are only identifiable at runtime. So the higher up ones are more nefarious. They're harder to spot. So they're more likely to cause bugs, and they're more likely to slow us down. Okay. So, what do these guys mean? I'm not going to dig into every single Connascence at the moment. What I'm going to do is I'm going to distribute some worksheets and ask each group to look at 2 individual Connascences. So the code base we've introduced 4 different kinds of Connascence. Connascence position, Connascence convention, Connascence of algorithm, and Connascence of value. I'm going to give each group 2 to look for. Most of the workshop now, we're going to read through, we're going to kind of go through the code base and try and identify all the places where the Connascences happen. What I'd like you to do is mark up your drawings to say, for each one, what's the impact, what links to what. Okay, so I'll hand these out. So you guys have got position and algorithm. You guys have got value and convention. You guys have got convention and algorithm. So I'm sort of, there's an explanation of each here. Yep. You've got algorithm and convention. Are you working as 2 pairs, or are you just sort of all working together? Okay, I'll give you those guys then. All right, cool. So we've got 1 hour now. I'll come and sort of chat with everybody and see how you're getting on. At the end, I'm going to ask you to kind of talk about the ones you were looking for. Somebody from each group just to talk about what you were looking for and the examples you found, so that you can kind of share, because you've got 2 and everybody else has got a different combination of them. So we're going to talk about these 4 different Connascences and then have a kind of general group discussion. If everybody gets done a bit quicker, then we'll just have a longer discussion, okay? So, as I said, I would like each group just to stand up and just do a quick chat about what were you looking for and what instances of Connascence did you find. Can I start with you guys over here and we'll just work sort of around the room? Okay. Any others? Did you find any more? No.
Yeah, there were more. The way the UI transmitted the instructions to catalog actions, warehouse actions, and basket
Yeah.
actions was just as simple parameters. There was no kind of checking of the instructions, so it's kind of transmitted. So all the checking is done in those. The checking, if you changed the order, you'd have to change.
Yes, absolutely. Yeah. Okay, great. What was the other one you had?
We had our algorithm, which was about sort of two areas having to agree on how they did a calculation. And the example we had for that was the discount is calculated both in the basket actions and in the basket. So if you change the way the discount is calculated, you would have to change it in both those places.
Yeah. Okay. Brilliant. Thank you. You guys?
Okay, cool. So we had Connascence of convention, which is where, like, for example, where the find function returns null when asked for something that doesn't exist in the database, and all the query that handles that null value has to agree that it's not found in the database. So the one that we found was a null example. Which was in warehouse. So the lookup method returns null, and it's used in several places to assume that there's no stock, but it might be that the item just doesn't actually exist. So using a 0 would probably be more sensible in that case.
Yeah.
Okay, and we had constants of value. Basically occurs when two or more values must be kept in a particular relationship to each other. So initially, I thought this was an example of a convention, but in the user interface, in the user command method, we have a kind of arbitrary kind of decision-making process where this command A means add to basket, B means display basket, and that's basically that links, I guess, the command to what this method returns.
Mm-hmm.
So is that why?
I think it's where, like, for instance, you know, the replenish command knows it's an R. It checks what the user input's been, rather than just saying, okay, I'm a replenish command. You know, they're coupled on R. If you wanted to change it to uppercase R in the UI, then you'd also need to change the downstream one, yeah. It's interesting you talked about the returning 0 instead of a null, so that would still introduce the same Kinesins.
Yeah.
So probably a nicer refactoring to do would be to make some kind of type that comes back from these lookups that has the information in it. Because then you've turned it into Kinesins of type, and type's fine, right?
Yeah.
We have to have type.
Yeah.
Yeah, so. Okay. You guys at the back there, please.
Convention as well.
Yeah, you'll start to see them repeat now, yeah.
Okay. So the other one was constants of algorithm. When two functions or algorithms need to know about how something works.
Yeah.
Get input, if they're storing something, then get it out. You need to know the format to get it out. And
Is that not convention and position, maybe?
well, the example here is like a hash table.
Yeah.
It's very similar.
Sometimes there's very blurry boundaries.
The problem with convention is, you know, position is a convention. So
Mm.
when they put up position, we had that down as convention, because convention is the position you need something, but it's a bit kind of woolly.
Yeah, I mean,
It's too wide.
you can. So convention think magic numbers in a database. You know, number 15 is a sort of product code. If where you might have an if, if input equals 15, then treat it as a product code. I don't know, some sort of user type, for instance. That kind of stuff. Where you might replace it with an enum. Generally, you want to replace stuff with types, right? Whereas position's much more like the order things have to happen in. So it's a bit higher. Yeah,
If
yeah.
it was using an array rather than some type of thing, that makes it really weird.
Yeah, I've said to a couple of groups, I've been rebuilding this code. Kevin wrote the code, and I've been rebuilding it in Kotlin recently, and it's just horrible. It's really, really hard because you can't rely on it, you know, doing anything sensibly.
Yeah, on the algorithm front, we found in the display basket command bit, in order to check whether the basket's empty, it actually calls a list method on the basket object to return a Java list of basket items and then checks whether it's empty, which is, surely all that knowledge should be in basket items, in basket, and it should have a is empty method on it.
I think so. I'm not sure it's Connascence of algorithm, though.
It's knowledge, isn't it? So what is it? It's a knowledge of what something that should be inside the class. Like the fact that it's a list.
I think it's more that that's convention. So it is type. So you've got Connascence of type there, the fact you're getting back a list. So somebody made the good point that, like in Ruby, some things are going to be different to Java in terms of severity. So the fact you're getting back a list of some things is okay. The fact that it's an empty list means there's nothing in the warehouse or nothing in the basket or whatever. That's a convention thing, isn't it? You know, I mean, you know, it's probably one you wouldn't call out straight away, but you would go, okay, right, if I actually did want to have other reasons why I could return empty, then you've got the couple in there.
An analogy I tried to use to imagine this is either some type of standard, like a measurement standard.
Mhm.
So if you've got two cooks in the kitchen, they have to agree on which measurement to use. And that, or if you want to build a rocket and you need to know if you're using imperial or metric. And that shared knowledge is the Kinesis of algorithm. That value, that standard that's being looked at, that the get and the put have to know. The example in the sheet of the get and the put have to agree on the hashing algorithm.
Mhm.
The hashing algorithm is the standard that the two members of the
Yeah, they have to have computed the thing the same way, the same way.
I guess that's why I found it maybe that, but identifying that because it's like they have to agree on the fact that they're stored as a list.
Yeah.
Whereas if I want to change that to a collection, Java, the code that consumes it then has to know that I've changed it.
But that's still Connascence of type there, isn't it? You know, we still have to have things agreeing that I'm giving you a thing of a type there. What that actually means, if two things have to, if something externally has to interpret that information in a way that should be internalized, that's where you've got the sort of higher forms. Yeah, it's it's tricky.
Something like a sorted set, if you was to, so the example is there's a sorted list in there. If you use a sorted set and you have to switch to a list, you're iterating over it. Is that the fact that it's sorted, that's a property of the type, but effectively that is, sorting is an algorithm. So therefore, what is it you're more dependent on? The way that the item is sorted, is that algorithmic or is it type? Because although the concrete type is different, the abstract type is still.
So the fact that you're, yeah. So the fact that you've got, so the abstract type in this case is the list then, right? If I understand right what you're saying. But the concrete could be a sorted list, then absolutely you've got some kind of Connascence of algorithm or Connascence of convention or something like that coming back, yeah. Yeah, because you're not dependent on the type, you're dependent on some way of interpreting what you read back. If you see what I mean, yeah. If you've hard-coded the concrete in, yeah, it's pretty horrible, but if you changed it, then it would have to change elsewhere. You would still need to then go and change that code. You couldn't easily just switch from a sorted to a non-sorted set. Okay.
You guys mentioned the bus, the discount being an example. Something like this.
So that was in the basket and bus actions. Can't remember which stuff it was.
Yeah. So you guys, did we do?
We had Connascence of convention,
Uh-huh.
and from that SQ code, we are compiling that string in so many places.
Mhm.
That means that SQ code might have
Yep, the structure of it, yeah. Okay.
We know that consists of position. We found out that replenish stock command, the order in which it's coming is affecting the, if you change the order in the UI, then it's going to affect the replenish. And
Yeah.
in Connascence of convention, we found that find method method response, it returns null.
Yeah, yeah. So the convention that null is empty is everywhere. Yeah. Okay, you guys.
Yeah, we also had convention. Something we had down as a convention originally, but in retrospect may have actually been positioned, was, as many people have said, that the SKU has this code property which is an array, and various things are depended on, and they may they would be the second index in that array.
Yeah.
That would change to become a different index.
Yeah, that's definitely position. Yeah.
We also had that SKU price is stored in pence and output in pound. So wherever it's output, it's divided by 100. Kinesis algorithm that we're looking at.
We found that SKU implements comparable for sorting. And then the warehouse also re-implements the exact same converted method independently and uses it to sort SKU.
Oh, good one. Good one. Yeah, that's a good one. It's not actually on the list. So crack it. No, it's interesting. One you said that there was something about. It's just escaped me. What was the one that you found that you said was position?
Oh, position. Sorry, SKU has this.
The SKU ID is stored in the
Yes.
index.
The SKU is
Ah, right. Yeah. Okay. Yeah.
index
Right.
the code property.
Yeah.
And that's a convention which is enforced across the code base.
Yeah. So the structure of the SKU. Okay. Are you guys?
Yeah, we found the same thing with SKU, which conducts research across defining the actual different array positions across every project. And any time we found there was usually all three of the actual 0, 1 and 2 is actually in the report. So the other 0 and 1, 2, 3 used in the
Yeah.
warehouse. That was position, yeah.
We had Kinesins of value also, and found that basket item holds these SKU ID, title, and price, but those are also specified in SKU itself. So if you were to add something to your basket and then change the price, you would have to change the price in the basket and into
Right.
the
Yeah.
property.
Yeah. So you got another two places. Okay. Did you guys? I mean, I know we sort of had a chat about.
We kind of all work like that.
Right. Yeah. Okay. Cool.
Most of your own skill.
Yeah.
That document implementation is
Cool. Okay, cool. So let's go through them all. See what ones we got and that. Okay, right. So Connascence convention catalog lookup returns null. I think most people who were looking at that got that. So that's coupling catalog actions in the catalog. Although we've got product, yeah. So that coupling's there. Catalog and lookup code, same thing. Convention, price is an integer of number of pence. Yeah, so there's this convention that we're dealing with, representing a price as 85, 364 sort of thing. If we want to move to a currency like yen or something that doesn't have pounds and pence, like the equivalent of pounds and pence, I'm sure there's a technical word for that, but then we would struggle, yeah. So that's coupling together the catalog actions, the basket actions. So there's this coupling going on here, which doesn't show up on the diagram. The catalog and the basket. So these guys. Yeah. So you see how this is starting to show us that there's stuff that we can't see there just by looking at the dependencies in the code. Yeah. Yep. Convention user input returns null when the arg is missing. So that's coupling the UI into the basket actions. The structure of a SKU code. I think most people saw that one. And so that's linking together catalog actions, basket actions, catalog, warehouse, and file store. So it's quite bad. I mean, that's taken us from here right down there. So we've got this very, very wide. Remember I talked about we've got the type of convention, we've got the extent, so how much is reaching together, and then we've got the reach. And so that one's got a big, scores big on the reach and the extent stuff. So algorithm's really hard to spot sometimes. I personally find it quite difficult anyway. So first one, basket.add is assuming that the skew exists and that's been checked by the caller. Really subtle. Okay, so basket.add function basically has no validation on it. It's assuming that the right things have happened. If you wanted to add, so that's coupling basket actions and basket, but if you wanted to add another thing that added things into basket, you'd have to implement the same algorithm. It's in the wrong place, yeah. And both know how to calculate the total. I think we've got a few people got that one. Now, there's a few cases where we're basically doing error reporting through unchecked exceptions. So the UI is assuming that everything downstream knows how to report back to the user through the exception. So all these unchecked exceptions that are all over the place, when they get raised, that just gets sort of splurged out to the user. Yeah, so that's Connascence of algorithm happening there. And price formatting, I think people kind of, did anybody get that one? Like how we actually format a price and do all this padding and all this kind of stuff.
Yeah, we noticed that the price gets transmitted to the file store as a string instead of converted into a number.
Yeah, so how to convert that into a price is the Connascence of algorithm going on there. Okay. Position, yep. The command char is arg0, so that's one. Actually, that kind of goes through quite a lot of stuff. Multiple method parameters is sort of everywhere. Structure of a skew code, most people saw that one. And the file layout, so the way that everything's laid out in the catalog file and the warehouse files, it permeates up through the position that data is stored. Comes up. Okay. Connascence value main knows the help command. Replenish command knows it's an R. The discount threshold and rate, I don't think anybody mentioned. Do you mention that? Yeah. So the value of a discount and the threshold, was it 20% or something like that? SKUs in the warehouse must be in the catalog. The file column delimiter is spread around a bit, so that's matching up like the catalog in the file store and the warehouse in the file store. And this 60 column display width, so there's some fairly nasty code in there that's kind of padding things out for display. Again, Connascence of value going on. Okay, so brilliant, right? Well done, everybody. Let's go through all this. So now we understand this a wee bit better. We can say, there's these connascences, the extent and the reach is important. Okay, and we can propose a different refactoring algorithm. Okay, so find the top level encapsulation units. We want highly cohesive top level packages that we can plug together in different ways. Yeah? Map the connascence, remove the worst, go down. Yeah. So we're coming back to the start of the presentation. We're saying, we do red, green, then what? Okay, so code smells, all the design stuff that we're taught, although it's useful, doesn't give us this sort of objective way of looking at things. Okay, and that's pretty much it. I'd like to have a bit of general discussion for the rest of the time. We've actually got about another 15 minutes or so, but there's a lot more information there. SiliconSpinach.net, so that's Kevin's blog, and he's got a series of articles where he's done test-driven development using Connascence as the only way of deciding what to do next. where he kind of talks through it all. Kinesins.io it describes each Connascence, what they mean. So the examples on the sheets were taken from there. If you want to talk to either of us, Kevin Rutherford, Mowat27, that's me. I'm on Twitter. And so, thank you. So in general, any comments, any?
What is our most Kinesis here, or where would we start with that?
And what is identity? Spell that one.
So, what is the worst? So identity is the worst one in terms of its distance, but there's probably, I'll come back to what it is. You've got to think that there's also the reach and the extent. So to my knowledge, there's nobody's actually done any kind of analysis on formalizing and giving these things numbers and plugging them into some kind of algorithm that you can apply. There's maybe some interesting research in that. Identity, I'm going to pop onto the internet and have a look at Kinesins.io because it. So we've got this site down. Everybody see that? Yep. Identity. So.
It's the most vague one of all.
Yeah.
I looked it up and went, everything else has got a lot in it, but that doesn't have a lot. It's not the most serious one.
So think, I'd say that's think sort of multi-threaded, where you might be, two threads might be holding a value, like a reference to something, but under the covers, are we holding onto the same instance or different instances? Yeah. So identity and value are sort of two different things, you know. President United States of America, you know.
Two equal things which aren't necessarily the same instance.
Yeah, you know. If I'm holding on to Barack Obama and you're holding on to Donald Trump, we can be off processing and making all sorts of decisions without actually agreeing that we're holding on to the same US president or whatever it might be. As an aside, if anybody's had any interest in Clojure, as a language, that's got a really, really strong idea about identity and values. So stuff that Rich Hickey talks about is really, really interesting. Yeah. And he's built a database and a programming language where it's very difficult to trip over these things. It's designed to be multi-threaded. Okay. Any other?
How does it relate to Afrin and different couplings? Is it about packages or is it?
Yeah. You need to remind me what they are.
So Afrin and different coupling is about the number of links into and out of packages and stuff. So
Right.
It's kind of about cross-package coupling. Again, it kind of comes from the same. I mean, Miller Page Jones's Practical Guide to Structured Programming, he kind of like touches on a lot of the coupling back then. Whereas I only became aware of this term in the newer stuff in like the last couple of weeks. But
Yeah.
obviously he covered coupling and cohesion along, years sort of before that. And he used that term. That's why I was wondering whether there was an because I couldn't find any obvious place where he kind of crossed over, or whether it was just like, I'm going to ignore those terms, I'm going to be on my own. So I was wondering.
I'm afraid I don't know, but it'd be quite interesting to look. I think that's, from what you say, I think that's related into the extent of the coupling, you know.
Yeah,
Do we?
Just at a general package level rather than that number of links, if you like, between them rather than the individual things within it. It feels like that's what it is, but that's what I'm curious to know how they.
And does he talk about how to deal with it in terms of, ultimately it sounds like something you want to reduce down to a series of types and names that, allow you to explore the world.
Yeah, I think it's just, you don't end up with like giant meshes that obviously couple
Yeah.
packages as much as you do within the package itself, so that you
mean, the Page Jones, I think, was quite a sort of theoretical kind of guy. This stuff here came from Jim Wyrick. He was the one that said, oh, actually, this is really interesting. We've got some computer science here. Let's try and apply it into the real world. Apply it to like our day-to-day activities. And Kevin's, he's picked up on this and he's been blogging and all the resources that I shared. So.
A slightly random question, but my assumption is that as you become more familiar with Kinesins, you're better able to see these kind of connections and patterns.
Yeah.
How long does that process take?
I have no idea. I'm still on the journey, so.
It really hurt your head, that, didn't it?
Some of it really did. I mean, some of it felt relatively intuitive, or like the kind of code smells I just sort of like cringe at, and I don't really know why, but they're cringe-worthy.
Yeah.
I was able to say, oh, that's this thing, right? It has a name, cool. But then some of the other ones, like algorithm, was really, really hard.
One of the things you kind of, it's the algorithm thing, certainly the calculation of discount, falls under the bracket of dry. It's all there. All these concepts are there. There's nothing new here except for saying if we can categorize things, we might be able to decide what to do more efficiently and more effectively. Because you can see that these things that are up here, because they can only be happening at runtime, they're going to be a bigger source of bugs. They're harder to find, they're harder to inspect, more likely that as you change things, you're going to trip over stuff. So therefore, what do we do as programmers? We're here to change stuff, really. And it's been, we've talked about this again and again and again through the conferences. It's something that keeps coming up, but, everything we do technically doesn't live in a bubble. We do good things technically because it makes it easier for us to change things when the world changes around us,
I think you'd have to do workshops at work before you even consider pairing with someone, like bringing up these concepts, because they'll just be like, what the fuck are you talking about? You need to put a lot of effort into being able to bring this into your team, I think.
Oh, yeah. It's early days in the research, You've had Page Jones, you've had Jim Wyrick, you've had Kevin Rutherford. Nobody else has really been talking about this, so it is a very, this is fairly sort of new stuff. It's not as widely circulated as code smelly.
Step coupling, temporal coupling, com coupling, those terms were all yours in
Yeah.
the late 60s, and even Page Jones kind of acknowledges that in his book in the kind of the 80s. And it feels like those terms have never kind of picked up. So it's interesting to see, there's timing coupling, there's temporal coupling, it was about go-tos that drop in the middle of code and that kind of stuff.
Ah, okay.
We don't have now, because we don't generally run go-tos.
Considered harmful and all that, yeah.
Structured coding just took that whole problem away.
Yeah.
And yet, some of the effects of that have come back under different names. Why
Yeah.
it's interesting, because a lot of this stuff comes out under old names, but even those old names don't seem to be used widely.
I think it's really interesting how some of the older concepts are starting to really kind of come back as people realize. You mentioned in your talk, I think, about design by contracts, something that people used to talk about, and it's gradually sort of inching his way back in. I think what we're seeing is the idea that if we just everybody does test-driven development, the world will be a better place, is proven to be not true. And the thinking tools that were introduced with the XP book 20 years ago, 15, 20 years ago, we still need to update these ideas as we go on. That's my view anyway. But yeah, I think coming back to what you said about how quickly you learn it, what I'm finding is as I learn a lot more about this, I can kind of see it. I can't always say that's that one or that's that one, but I start to see it at all sorts of different levels. We were constructing some sort of infrastructure as code stuff at work, and we had a guy in to help us, and we were talking about how we structure Terraform configs, which is basically a language for saying, like, scripting AWS and scripting cloud providers. We were talking about where to store the code, and I'm like, oh, wait a minute, if we put some over there and some over there, we've got a Connascence of something, So it applies, but I couldn't really put my finger on it. I just knew that that was wrong, you know. So what I'm doing in my own learning is I'm working on through Kevin's code. I'm re-implementing it in other languages. I'm sort of trying to learn a lot more about how this stuff works. But you know, I'm very much in Diana's sort of like kind of, what did she say? Learning out loud or learning publicly. I'm sort of in that sphere. I just hope that everybody at least got some sort of thinking out of today's session. Okay, so yeah, please do think, talk, chat, shout, come and have a chat with me on the beach later. Talk to me on Twitter. And thanks again to everybody for coming. Really appreciate it.